Good morning, and this is going to be lecture number 12. So we will continue from where we left in the last lecture, right? So we were talking about expectation, okay, and the variance of simplest random variables. So we started with the discrete random variable, right? And we have discussed many things, okay? So in this session, again, I'm just going to talk about some of the elementary operation, elementary properties of expectation. Okay. So without spending much time, let us move to the whiteboard, right? So this is going to be lecture number 12. Okay. And I'm just going to talk about elementary properties of expectation. Okay. Elementary properties of expectation. These are the observation that you can I think everybody knows the definition of expectation, right? So definition is very clear, right? If I recall the definition here, so definition is gonna be expectation operator operates on this random variable x, that is going to be giving you, if it is x is a discrete random variable, so the value that the random variable takes is small x times the probability mass function, right? Okay, over all x you can say, okay, over all xi or over all x you can say. Okay, so what you can conclude here is suppose the value taken by the random variable is greater than 0, right? Greater than 0, okay, or equal to 0 you can say, and the probability should also be greater than or equal to 0. Probability mass function is nothing but the probability only, and then overall summation is going to be what? Then overall summation, right? This expectation will be positive. So please remember this point, okay? uh, from the definition itself you can decide expectation is going to be positive as long as this x is greater than or equal to 0, and the probability, from the basic axioms we know that probability is always positive only, right? Or 0 you can say, or non-negative we call it, non-negative. Okay, so if the random variable is positive, right, the very first property is what? If the random variable is positive, okay, if the capital X is greater than 0, right? If the capital X is greater than 0, then expectation of x, okay, that operator operates on this x must be also equal to 0, right? Greater than or equal to 0, okay, for all you can say x, understand? So suppose your random variable x, okay, the value taken by the random variable x lies between a and b. Second property, suppose capital X lies between a and b, okay, therefore then your expectation will also be in between, okay, a and b. Okay, suppose any probability mass function is given, and it is distributed, okay, between you can say x and y. The random variable takes the value between x and y, so your expectation will also be lying between x and y. So this is the property, right, that you can use to answer the question very quickly. So some of the options that you can eliminate as well. ठीक है, देखो अगर मान लो random variable जो है, if it takes the value, okay, between two integers, a and b, I'm talking about discrete random variable at this moment, ठीक है? So your expectation is nothing but the central value, you can say central tendencies, right? In statistics we call it central tendencies, right? So expectation is going to be between a and b. Okay, so with this property you can always eliminate okay, you can eliminate some of the things. Okay, you can also prove it. Okay, I don't have any problem, you can prove this also, right? Okay, you can prove it. So what you can do here is, if you want to prove, right, so you can recall the definition only. So let me recall the definition. So what is the definition of random variable? Random variable definition is the expectation of x summation, the value taken by the random variable is small x times the probability mass function. Okay, the style you have to always remember. If we always write this capital X in the subscript, okay, just to denote that we are talking about probability mass function for x random variable, right? We can also write p by P by means what? The probability mass function corresponding to by random variable. So you know, in the same sample space, we can have many random variable, right? We can have many random variable. I have shown you also, right? So remember, these are the notations, okay? Suppose this is the situation, and if x takes the value small a, you can say, right? If x takes the value small a, okay? Suppose x is between, you can say that a and b. So what you can do here is, initially you can take x equal to a, right? So if you take x equal to a, then you put here a probability mass function x, right? Okay. So this is a is constant here, so a you can take out, right? A you can take out. You see this, okay? So this will be a only, because you know, we know that the total probability must be equal to 1. Okay, so this will be a. Okay, if you take x equal to a, right? So your expectation is going to be a only. Okay, it is very simple. You can also take, you know, x equal to b. Okay, so your expectation will be either a or b, or in between the two, right? And suppose any constant is given, the third property. If c is a constant, if c is a constant, okay, so if you try to find the expectation of this constant value c, okay, what is the expectation of the constant? If someone is going to ask you what is the expectation of the constant value c, so I think many of you can tell now the expectation of the constant is going to be the constant only. Yes, you can prove also, yeah, you can prove it. So expectation of the constant is going to be constant, right? So as long as you know, you can say the random variable takes the value c, and the probability is going to be 1 only, because there is only one value of the random variable c. So this will be constant only, right? So you have to remember like this: the expectation of the constant can be anything, will be constant only. Okay, so expectation operator, you can also prove it. I need not to prove, but you can. Okay, so how to define expectation? Take the random variable value times the corresponding probability of that random variable. Okay, so here you see, in this case, expectation of c is nothing but the value taken by the random variable is c, and the probability of c is nothing but 1. So c times probability of c, which is nothing but c only. So this is kind of a proof. You can say just prove it. Okay, prove it. Okay, fine. So these are the properties that you have to remember, right? These are the property that you have to always remember it. Understand? So now we will discuss about expected value rule. Okay, expected value rule is also very important. So what is this expected value rule? Dekho. Suppose you have to calculate. Okay, remember this is important concept, right? Okay, for calculating expectation of the function of the random variable x. Okay, suppose you're not directly computing the random variable expectation of the random variable x. Okay, you are not directly computing the random expectation of the random variable x, you are computing the function of the random variable x. Okay, there is a g. Okay, now your random variable is not free here. Okay, it is inside the function. Okay, g of x. So you have, so for calculating, like suppose x is given as, you know, function is given as sine x. Okay, sine x, right? So sine x is a random variable, but sine is g here. Okay, so expectation of gx अगर आपको compute करना है, so you have to go for expected value rule. Okay, we call it expected value rule. Remember this formula, expected value rule. Okay, it follows the definition only, right? Expected value rule. Please remember this formula. Okay, whenever you will be having this kind of situation, whenever you have to compute, okay, expectation of g of x. Understand, expectation of g of x. So you have to use this formula. Expectation of g of x, okay, is nothing but the summation. Okay, remember this summation. Understood? Summation is g of the value taken by the random variable x times the probability mass function of x. Okay, so your expectation of g of x depends upon the probability mass function of the random variable x times the g of x. Okay, and I'm just going to prove also this. Okay, I will prove it. Okay, over all x, you can say over all x. Okay, so I will take one example and I will show you, okay, how efficient this expected value rule is. Okay, so if you remember this formula, then your life will become very easy, right? Okay, so suppose let me take one example, okay, so that you guys can understand that. Okay, example to understand this expected value rule. Okay, so example here is what, suppose you consider here the x is a random variable, right? Let me take x is a random variable. Let x be the random variable. Okay, let x be the random variable and let capital Y is nothing but g of x. Okay, x is a random variable. Okay, and we have to also consider y equal to g of x, right? Y equal to g of x. Okay, so suppose we want to find the expected value of y. If we want to find expected value of y, okay, so random, whatever value the random variable takes in the question, they have also given. Okay, I'm just going to show here. So suppose this is nothing but a random variable x. Okay, so whatever value it takes is given here. Okay, you can say like this. Okay, so it takes 5 4 3 2 5 4. Oh, I should write here, right? 5 4 3 2, right? These are the value taken by the random variable x, right? And we have some corresponding probabilities also, you can say, right? Some corresponding probabilities. Okay, this is nothing but a mapping. Okay, mapping from sample space to the real line. Okay, and corresponding probabilities are also given, like, it is given as 0 0.4, 0 0.3, 0 0.2 and 0 0.1. These are the probabilities, okay, given. Okay, now there will be another function g. Okay, g is going to operate on x. Okay, so you will get by. G is going to operate here, so you will get by kind of a situation, right? So this is new random variable by you are going to get. Okay, the value taken by the random variable is by. Now what are the value that you're going to get is nothing but, suppose this is 5 4 3 2. Okay, but when you take the random variable g, sorry, when you take the new function g, okay, which is operating on the random variable x, so you're going to get what, by, as a new random variable, by equal to g of x. Okay, so it might happen that this 5 is going to get mapped to 4, 4 is also getting mapped to this. Okay, this 3 is getting mapped to 3 and 2 is also getting mapped to this. Okay, so you guys see here, now y is taking only two values, 4 and 3, right? Y is taking only two values, 4 and 3. Okay, so we can find out the average over y, right? How to find average over y, guys? If someone is going to ask you what is average, let me calculate here. Average over by, you can say, that is nothing but expectation of by. So if someone is going to ask you expectation of by, so from the formula what we know, expectation definition, from the definition you should say, this is going to be random variable takes the value by and the probability mass function corresponding to random variable by. Okay, this is the definition we know, right? Okay, if any random variable by is there, so you need to know the value taken by the random variable by and its corresponding probability mass function. Okay, so you see what you are doing, right? You need to know in this case, if you are going to use this concept, right, directly, if you are computing the expectation of the random variable by, which is nothing but g of x only, by equal to g of x, right? So if you are directly computing the average value of by, then you need to know the probability mass function here of the random variable by. But if you have the concept of expected value rule, right? So I will show you. If you know the expected value rule, okay, you don't have to compute separately the probability mass function for the random variable by. That is the, kind of concept that you should know, right? That is the most, you can say kind of advantage over, if you're going to use expected value rule. That's what I wanted to show you here, right? So अगर मान लो तुम्हें डायरेक्टली निकालना है, so you need to know this. Okay, so can you compute now? So random variable takes the value 3 here. You see, first random variable is by is taking 4. Okay, and what are the probabilities? For by equal to 4, the x should be equal to 5 or x should be equal to 4, right? So corresponding probabilities are nothing but what? 0.4 and 0.3. So you have got choice here. If you want to get 4 here, okay, if you want to get 4 by equal to 4, so you can get 4, okay, which is nothing but what? By x equal to 5 or x equal to 4. So their corresponding probabilities are what? 0.4 and 0.3. So you can say that here it will be nothing but 4 times 0.4 plus 0.3. Okay, this is going to be the probability mass function for by, and now 3 is there, right? You can say 3, this 3. So if you want to get by equal to 3, okay, so you have to come back to x, right? So you have the choice here, right? Either you can take x equal to, x equal to 3 or x equal to 2. So their corresponding probabilities are, you have to add it, okay? You have to add it, 0.2 plus 0.1. So 3 times 0.2 plus 0.1. Now you can compute this. So it is nothing but. So you can just write like this only, okay? You don't have to solve completely, right? So this is nothing but we are averaging over by. What we are doing, we are averaging over, you can write here, averaging over by. Now if you're going to average over averaging over x, if you're going to average over x, guys, right, small x, you can say this is small by averaging over small x, okay? So can you tell me what will be the situation here? Yes, so you can say that 3 times what? Averaging over x. Okay, you are going to compute the averaging over x. That is nothing but 3 times what? If you take only x value here, okay, only take x value here. So that is nothing but just multiply this 3. Okay, you have to just multiply this guy inside. Okay, so let me show you. So for this, you have to take the value taken by the random variable by here, right? That is 3, and that correspond to these probabilities, and these are the probability of what? Probability of getting x equal to 3 and x equal to 2, right? So you can say that this will be equal to 3 into 0.2 plus 3 into 0.1 plus, okay, you come to here, probability, the value taken by the random variable by is 4, right? So you come to on x now. So this is 4 and this is this. Okay, so 4 into what? 4 into 0.3 and 0.4. Okay, 4 into 0.4 plus 4 into 0.3. So I think you can now see, okay, if you're going to find the average over by and average over x, both are same only. If you match it, okay, this and this both are same. What is the only difference that you have to observe here is, आपको क्या यहाँ difference मिल रहा है कि you don't have to find, okay, you don't have to find the probability mass function explicitly for the random variable by in this case, okay? So second way of finding this averaging over x is nothing but what? Using the expected value rule. Okay? So I think this is clear, guys, right? So this is nothing but the expected value rule only. So if you want to find the expectation of bi, that is nothing but expectation of g of x, which is going to be g of x. Okay, you have to take the g of x. Okay, like we have taken here 3 and 4. They are the g of x value times the probability mass function of x. That's it. So this is nothing but a expected value rule. Okay, please do remember this concept, very important. Okay, you don't have to explicitly calculate. Okay, you don't have to explicitly calculate what the expectation, sorry, this probability mass function for random variable bi. And one important point that you have to remember, suppose you have got g of x equal to, example, suppose you have got g of x equal to x square, you can see this is given, g of x equal to x square. Now if you want to find expectation of x square, so how you will write using expected value rule? It will be x square probability mass function of x. Please don't take, okay, don't take it like it is equal to bi, then try to compute the probability mass function for bi and then do. Directly you can do, because random variable x and its probability mass function will be given in the question, right? So I think this is clear. And one important you need to be you have to be careful, be cautious. What kind of caution you need, right? You need to be cautious somewhere. So you have to remember that expectation of gx is not equal to, expectation of gx is not equal to the function of the expectation of x. ये पॉइंट आप याद रखना हमेशा. Okay, expectation of gx is not equal to the g of the function of expectation of x. Okay, what is the meaning of that? Suppose you take expectation of x square is not equal to the expectation of x ka whole square, because here the function is nothing but squaring. Okay, so expectation of x square is different thing and expectation का whole square is a different thing, right? So ये point आप हमेशा याद रखना है, ये this is important. Okay, sometimes in the interview they might ask you, right? So have you understood the advantage of using expected value rule? Okay, you don't have to explicitly find the PMF for the new random variable bi, you can say. Okay, I think this is clear. And there is one more concept called linearity of expectation, sir. Linearity of expectation. Linearity of expectation. So expectation operator is nothing but linear. Okay, linearity of expectation. Okay. So let's say suppose you have got the random variable, I mean the expectation you are trying to find of this kind of situation, ax plus b, and this ax plus b is nothing but a straight line equation, you can say, right? Okay, so if you are trying to find expectation of ax into b, so you can just, this expectation operator will operate inside this bracket. So expectation of ax plus expectation of b, right? Because expectation is a linear operator, so a will come out. So this is expectation of x plus this is b, because expectation of the constant is constant. So let me take one example here. What this example says, that suppose x is nothing but a salary. X is nothing but a salary, you can say, right? And then if I ask you what is expectation of x, so expectation of x is nothing but a average salary of a person. Average salary of a person, right? So let me take bi. Bi is the new salary. new salary, okay, and that is given as 2x plus 100, right? This is new salary which is 2x plus 100, okay. Now what is the average salary then? How to find average salary? Average salary of the buy is going to be buy equal to what? 2x plus 100. That is 2 times of expectation of x plus 100. If the salary of a x is known, right, you can say first salary is known, then you can, or you can say average salary, you know, right, then put it and you will get the answer, right? Okay. So I think this is clear. Sometimes it might happen that expectation of gx is equal to g times expectation of x. Sometimes that whenever g will be exceptional, okay. Okay. So please do remember that. So this is over, guys. Okay. Okay. If g is going to be exceptional, right? If g is kind of exceptional, then expectation of g of x is going to be equal to g of expectation of x. ये भी possible है, ठीक है? But not always true, okay? So I think this is clear for all, and this is you can say the discrete random variable, okay, and where we have discussed the uh, the expected value rules, okay, how to compute expectation, so on and so forth, okay. Now what we will talk about next kind of centered tendency, like we will talk about variance and the standard deviation, right? We'll talk about variance and standard deviation, okay. So what is this variance? Okay, we are going to talk about variance. And now, remember that we are talking about discrete random variable only. At this moment, in fact, in all the lecture, I did not talk about continuous. Okay, I have to conduct separate session on continuous. And continuous is only important for your GATE exam. Discrete is also important, but continuous is more important compared to discrete, okay. So now we will talk about variance. What is this variance? Okay, after expectation or a mean, we need to discuss this variance. Okay. So at this juncture, we did not talk about the continuous random variable, right? Okay, after finishing these things, at this juncture we are just talking about mean, expectation, variance for simplest random variable that we can imagine. And I think I have discussed all the simplest random variable, yeah. And I think you guys might have appreciated the Poisson intuition. Okay. So variance, what is this variance, guys? अगर हम बात करें, what is this variance? So variance is nothing but suppose you have got a PMF, the probability mass function. See, I'm talking about discrete random variable. So I will consider PMF, probability mass function. But when we will talk about continuous random variable, so in that case, we will talk about probability density function, sir. Probability density function, okay? So variance is nothing but what? A measure of spread of the, PMF, okay? Spread of the PMF, right? Spread of the PMF. So variance is nothing but a measure of a spread of PMF. Okay, measure of the spread of PMF, right? Measure of the spread of the PMF, right? Okay, okay. So this is the basic definition that you can understand. But what will be the mathematical definition? What is going to be the mathematical definition? So to be able to understand variance mathematically, we need to take one random variable first. Okay, that random variable is nothing but take the random variable. You can say consider the random variable. Okay, random variable x with the expectation. You can say expectation of x. Okay, you should know this, right? If random variable x is there, so its expectation is expectation of x. इसको आप बोल सकते हो सर म्यू, which is nothing but mean. So we represent the mean with the help of mu sometimes. Okay, please remember. Instead of writing expectation of x, we can also use this word mu. Okay, sorry, this letter mu. Okay, Greek letter mu. So random variable x is there, and its expectation or a mean is going to be mu. Mu is expectation of x. And if somebody is going to ask you what is the distance from the mean, right? What is the distance this random variable has from the mean, right? So you can say that like this. Suppose this is nothing but kind of, PMF is given. Okay, this is PMF. Okay. So let me say that this is going to be your mu here, and this is going to be your random variable x. It takes some value, you can say. So what is the distance between these two? Okay, like what is the distance between random variable and the mean? So that is nothing but second point. So you can say distance, okay, distance from the mean. Okay, this is nothing but your, you can say deviation, right? X minus mu. Distance from the mean. Okay, so whatever observation you have, whatever random variable random variable takes the value, how far they are from the mean, you can say. So x minus mu. So random variable you have taken, that is x, its expectation or a mean, that is mu. Now distance from the mean is x minus mu. Okay. Now if I ask you what is the average distance from the mean, average distance from the mean, average distance from the mean, right? So how to find average? That is nothing but expectation of x minus mu. So expectation of x minus expectation of mu. You know that expectation of x is nothing but mu minus, what is, see, mu is nothing but your constant only, guys, right? So this is also mu, so which is nothing but 0, right? So average distance from the mean will always be 0, guys. Average distance, okay? Distance from the mean is x minus mu, which is non-zero, okay? But average distance from the mean is going to be 0, right? And how to find average distance? Allow expectation operator operate on the random variable, like, x minus mu, that's it. So the way I'm speaking, please note down all these things. Okay? These are very important concepts. Now, so this is where the definition of variance comes. Average distance from the mean is nothing but 0. But if you take the distance from the mean and square it and then find the average, take the distance from the mean, that is x minus mu, and square it and then find the average. This is nothing but definition of variance. Okay, this is the definition of variance, guys. And this is a definition symbol, okay. This is nothing but the definition of variance, okay. So what is the definition of variance? And this must be always positive, guys. This will be always positive, right? So I think this is clear, right? Okay. So this is one of the first definition of variance, right? You can say that definition of variance is going to be what? We call it variance of x is going to be expectation of x minus mu whole square. Now, if you know the expected value rule, how do we compute variance? The question is, how do we compute variance directly? If you want to compute variance directly, so computing variance directly, right? Computing variance by using what? By using expected value rule, sir, because this is nothing but kind of g of x only, right? So by using expected value rule, okay. So this is nothing but a definition of variance, right? So the variance of x is going to be expectation of x minus mu whole square From the expected value rule, it will be summation small x minus mu whole square and the probability mass function of x. It's a very simple situation, sir. For all x, you can say. Hmm? Since what we have done here is we have considered the random variable x is nothing but x minus mu whole square. This g of x is nothing but x minus mu whole square. So if you want to compute the variance, right? So please remember the expected value rule, okay, that we have seen, because variance is nothing but what? The expectation of the average of the distance from the mean square of the average of the distance from the mean. And sometimes, let me tell you guys, this method is also very cumbersome, right? It takes a lot of time, okay, and the steps are going to be many. समझ गया ना? तो हर आपको डिसाइड करना है कि वेयर वी हैव टू यूज एक्सपेक्टेड वैल्यू रूल, वेयर वी हैव टू यूज वन ऑफ द फर्दर कॉन्सेप्ट दैट आई एम गोना टेल यू. एक और हम बताते हैं, ये तो डेफिनेशन है, डायरेक्टली यू वांट टू कंप्यूट डेफिनेशन, ओके. And if you take the square root of the variance, right? So standard deviation is defined as what? Standard deviation. Standard deviation is nothing but square root of the variance of random variable x. So यहाँ पर आप लिख सकते हो, this is nothing but expectation of x minus mu whole square, which is nothing but summation, right? X minus mu whole square, the probability mass function x. Okay, this is the standard deviation. Standard deviation का मतलब क्या होता है? You take the square root of, okay, square root of the variance, right? And we denote it by, we denote this by sigma x, okay, sigma x, sigma, like this, okay. And let me talk about properties of the variance, guys. The way we have discussed the properties of the mean, properties of variance. Properties of variance. What are the properties of variance, right? The properties of variance, first of all, you need to keep in mind that the notation that I'm going to use is here, the mean is nothing but mu, expectation of x. We can replace expectation of x with the mu, right? Okay. And you have to remember that suppose we are taking the variance of ax plus b, and so this variance is going to be operating on this, you can say, variance of ax plus variance of b. So this variance is going to be what? This a will come out, sir. A square, it will be variance of x, okay, and the variance of the constant is always 0, guys, right? Because b minus b will be 0. Okay, random variable takes the value b and the mean. So first of all, you need to find the distance from the mean, and there is no deviation at all, so answer will be 0, right? So a square variance of x, this is nothing but a variance of this, okay. So if you add constant, does not make any difference in the variance, okay. Understood? So this constant is going to come out, okay, with a square, but in case of expectation, it is directly taken, okay, out. Understand? So fine. So let me take one new random variable, that is nothing but by. Okay, let me define new random variable by, which is x plus b, okay, which is x plus b, okay. Okay. Now can you tell me what will be the expectation of by, sir? Expectation of by is going to be expectation of x plus b, which is nothing but expectation of x plus b only, which is mu plus b. So expectation of by is going to be what? Expectation of by is going to be mu plus b. Okay. And you can say this is nothing but kind of you can say gamma. Okay, like This is nothing but expectation of bi. We are just denoting by some gamma, or expectation of bi only you can write, no problem, because you might get confused also, right? Now if I want to find what? What I want to find? I want to find variance of bi, sir. Random variable bi, okay? So what we can do here is, we know that the expectation, if we want to apply direct definition, अगर आप directly definition apply करते हैं, तो random variable bi is there. So first of all, you need to see the difference, I mean distance from the mean. How far this bi is located from the mean, right? So bi minus the bi minus the mean of the random variable bi, that is nothing but what? Mean of the random variable bi. You can say expectation of bi. And then you have to take the square. Okay. Then you find out the expectation. Okay. So what we can do here is, we can write this as, now what is capital bi? Capital bi is nothing but x plus b minus. What is mean here? Mean is mu minus b. And you just take the square of that. तो यहां से कुछ कैंसिल भी हो रहा ना सर, यू कैन कैंसिल इट, तो बी बी कैंसिल हो गया, चलो बहुत अच्छी बात है. ओके, सो दिस बिकम्स एक्सपेक्टेशन ऑफ x minus mu whole square, sir. X minus mu whole square, that is nothing but the, how far. So what is this, guys? It is very simple, na? It comes out to be variance of x only, sir. This is nothing but variance of x. So what you are able to conclude here is, the variance of bi is equal to the variance of x. If by, suppose any random variable x is there, and if you add constant to that random variable x, your variance is not going to change. Your variance is not going to change. Okay, remember this. Addition of a constant, see, multiplication by any constant to the random variable will change your variance, but addition of a constant, okay, to the random variable x is not going to change your variance. Okay, please remember that. Okay. So with the same analogy, what we can do here is, suppose we have got bi equal to ax plus b, bi equal to ax plus b, right? So what is the expectation of bi, sir? Expectation of bi is nothing but a mu plus b, right? A mu plus b, okay? A mu plus b. Or what you can do here is, you can forget about this b here. अगर आप इसको इस केवल y equal to ax देखते हो, if you look at y equal to ax, so what is the expectation of y, which is nothing but a mu, right? A mu. So if someone is going to ask you what is the variance of y, so I think again you will apply the definition. Expectation of the y is nothing but ax minus the mean. इसको आप स्क्वायर कर दो. So from here you can say that this is nothing but a square x minus mu का whole square. So a square will be out. This is nothing but expectation of x minus mu whole square. And ये क्या है? This is nothing but a square variance of x. So आप देख सकते हो, if you take the, from here we have proven, right, variance of ax is nothing but a square the variance of x. So you can prove it. Okay, you take the constant, square it. Okay, ठीक है. So one of the very useful formula that I'm going to introduce here, okay, and this formula can be used, okay, in place of definition, sir. ठीक है. Rather than using definition, okay, all the time, you can use this useful formula, right? So what is this useful formula? Okay, to compute variance. Okay. व्हाट इज दिस यूजफुल फॉर्मूला फॉर कंप्यूटिंग वेरिएंस, राइट? अगर आप ये याद रखते हो तब तो फिर लाइफ आपकी बहुत सिंपल है. तो वेरिएंस ऑफ एक्स is going to be the expectation of the x square, sir. In future you will come to know this is known as mean square value. Mean square value, okay? Mean square value, we call it mean square value. Expectation of x square minus the mean ka square, square of the mean, you can say square of the mean. See, both are different thing, okay? Expectation of x square minus the square of the mean. So this is one of the very important formula, right? It is not a definition, guys, it is a formula, and you can prove it. From the definition only we are getting this useful formula, okay? You can prove this, okay? So how to prove this? ये याद रखना please. Yeah. How to go through this, how to read this. Variance of x is equal to expectation of x square, and how to find expectation of x square from the expected value rule, which is nothing but summation x square, the probability mass function of x. This is the formula. And how to find expectation of x, sir? Summation is small x, this, and then you have to just square it, subtract it, okay? So just take the definition of the variance, proof. If you want to prove this, how to get this formula. So so what we can do here is, we know that variance of x is defined as expectation of x minus mu whole square. So we can expand this, right? So this is x square plus yeah, this is nothing but 2 mu capital X plus mu square. Okay, now we can just expand this from the linearity. So expectation of x square minus 2 times the expectation of mu x plus the expectation of mu square. Now you see, guys, expectation of x square and ये mu common आ जाएगा, right? And expectation of x is mu only, right? You know that expectation of x is nothing but mu. So this becomes the expectation of x is let me write this mu square my plus ये क्या है आपका? This is mu square only, because mu square is a constant, okay? So this is expectation of x square minus what? The mu square. और इसको आप कैसे लिख सकते हो? एक्सपेक्टेशन ऑफ एक्स स्क्वायर माइनस द एक्सपेक्टेशन एक्स का होल स्क्वायर. सो आई थिंक फ्रॉम द डेफिनेशन, ओके, ये कहां से है? बाय डेफिनेशन. By definition you are getting this useful formula, okay? So I think this is clear for all, yeah? From the definition you are getting this useful formula, that's it. So till now you were only familiar with the formulas, right? But I'm trying to prove in front of you everything, and with the confidence, yes, you can do it, okay? So see, rather than memorizing something, see, you are supposed to forget after some day, remember. But if you're going to derive something, it is going to stay in your brain cell for the longer duration, okay? That concept you have to remember. So if you're going for machine learning or data science or communication, like whatever, right? If you're going into IIT or ISC to pursue your higher studies, and if you want to contribute something in real sense, देखो, जॉब करना इज अ डिफरेंट थिंग, राइट? अगर आप कुछ कंट्रीब्यूट करना चाहते हैं अपने लाइफ में, तो आपको थोड़ा सा यू हैव टू एक्सेप्ट दीज डेरिवेशंस. डोंट रन अवे. देखो कितना मजा आया ना, ये कान पकड़ रहे हैं, ये कान पकड़ रहे हैं, दैट्स इट, राइट? ओके, वी हैव गॉट द डेफिनेशन एंड वी आर गेटिंग यूजफुल फॉर्मूला. Okay. Now let us compute the variance of the simplest random variable, right? So variance of Bernoulli random variable. Okay, Bernoulli random variable. And it is very simple. What you can do here is, can you recall the Bernoulli random variable? The Bernoulli random variable, right, is nothing but the random variable x takes the value 1 with the probability p 0, 1 minus p, right? These are the two values that the random variable, Bernoulli random variable take, okay? And the parameter only is p. So can we find the random variable, the expectation? So what I will do here is I will try to find the variance with using definition as well as the useful formula. So you have to decide which one is easy. Okay, you can decide which one is easy, right? So देखो पहला हम यूज करते हैं by using definition here, by using definition. What is definition, sir? Variance of x is going to be expectation of x minus mu whole square. ठीक है, x minus mu whole square. Okay, so what is the mean of this guy? So mean आप find कर सकते हैं. Mean is nothing but 1 time p plus 0 times 1 minus p, which is nothing but p only. So your mean is nothing but p only, guys. Okay, your mean is nothing but p. ठीक है, your mean is nothing but p, right? So इस यहाँ पर आप expected value rule, okay, this is by definition. Now invoke the expected value rule. So expectation of x minus mu whole square and the probability mass function of x. Okay. So x minus mu, right? So x is 1 and the mean is p, right? So 1 minus p the whole square times the probability is also p. Okay, then this will be 0, so you don't have to write anything, right? Okay, but make sure that, I think this is clear, right? 1 minus p square and then this. Now plus x is 0 here. Okay, this is the mistake people do. X is 0 here, so you have to write 0 minus mean is p whole square and the corresponding probabilities is 1 minus p. What most of the homo sapiens make mistake is, that is common mistake, we think that okay, x is 0, capital X is 0, so it will be 0. No, in case of variance it is not. In case of mean, yeah, ठीक है, ये mean है, expectation of x. So now you can expand this guy and further you can do it. So this is nothing but 1 minus p whole square times p, and this is plus p times 1 minus p square, right? p square 1 minus p. या चलो अब हम फर्दर करते हैं. So variance of x is nothing but 1 minus p square times p plus p square 1 minus p. So you can solve this. 1 plus p square minus 2p times p plus p square minus pq. Okay, you can take p square inside. So this is p plus pq minus 2p square plus p square minus pq. Okay, now something is getting cancelled from here. Yes, you can cancel them. अगर कुछ कैंसिल हो रहा है तो आप कैंसिल कर सकते हैं. ठीक है, so here you see this is going to be minus this is p square, so here p times 1 minus p. So variance is simply what? The multiplication of two p and 1 minus p. Very simple. See how lengthy it was, right? See, by using definition, okay, of the variance, right, it is taking a lot of time to compute this variance, right? But for the exam you have to just remember the formula p times 1 minus p for variance, and for mean p. Okay, both are different, mean and variance both are different in case of Bernoulli random variable, right? These are the observation. But what you can do here is you can use Dheeraj sir method, right? By using the useful formula. By using useful formula. See, this formula is going to be very useful. The reason is, you get this formula by deriving, by further, expanding, manipulating that definition of the variance, right? So why you're doing the same thing, okay, it's better to use formula. So formula is nothing but variance of x is going to be expectation of x square minus expectation का whole square. तो आपको यहाँ पर डेफिनेशन लगाना है एक्स स्क्वायर मींस 1 स्क्वायर टाइम्स द प्रोबेबिलिटी, राइट? यहाँ पर फॉर्मूला क्या होगा, एक्स स्क्वायर करस्पॉन्डिंग प्रोबेबिलिटी मास फंक्शन माइनस इसका तो एक्सपेक्टेशन ऑलरेडी ऑलरेडी यू कंप्यूटेड ना, दैट इज पी स्क्वायर. P is the expectation, so P square. Now it is nothing but 1 square times the probability, that is P minus P square only, because next random variable is 0, it takes the value 0, right? So it is P minus P square, P times 1 minus P. So which one is very easy to compute, right? I mean, which method is good? So I think using this formula, useful formula, is good rather than that. Okay, so I will go for this. Okay. So after watching these things you will appreciate, हाँ sir ये सही बात है, ऐसा हो रहा है. Okay, so you can plot also, right? You can plot, since your probability is gonna lie between 0 to P, right? So if you try to plot this, this is variance of the Bernoulli random variable is P times 1 minus P, or P minus P square, right? So your variance is going to be looking like this, 0 1, and it is going to be maximum at 1 by 2. This is 1 by, you can say, 4 kind of thing. This is variance, okay, as a function of P. Okay, variance as a function of a probability P. ठीक है. So this is the Bernoulli random variable variance. Okay, please remember these points. And if I ask you that what is the variance of uniform discrete random variable, right? Okay, that also you can compute, okay, by using the formula only. Okay, so variance of uniform discrete random variable, okay, what is this? क्या हो जाएगा बताओ? So first of all you can recall, right? So your probability mass function, if it looks like this, suppose n equal to something is there, right? There are samples, okay, like this, and so on, okay, from 0 to n. This is nothing but a probability mass function. What is this height, guys? So total, you can say this is n number of samples, so n minus 0 plus 1, which is n plus 1. So the probability is gonna be same, that is 1 by n. Okay, and the variance, I would suggest to use the by formula. So by formula, the variance of x is going to be expectation of x square minus expectation of a whole square, right? So expectation of x square, right? So how to compute that? 0 times the probability, okay, 0 square times the probability, okay. So you can say that it is very simple. So 1 by n plus 1 will be common. 1 is 0 square, 1 square, 2 square, 3 square, plus n square. This is nothing but conjugative natural number square, right? So that is n plus 1 to n plus 1 by 6 something. That formula we can recall, right? N plus 1 to n plus 1 by 6. And the mean for this, I think we have computed already. That is nothing but n by 2. mean for this is half. Okay, mean is gonna be half. Okay, n by 2, 0 plus n by 2, that is okay formula. So this is n plus 1, and this from the definition n plus 1 to n plus 1 by 6, we know that minus n by 2 होल स्क्वायर. सो इसको भी आप कैंसिल कर सकते हैं यहाँ से. So your variance is going to be 2n plus 1 n into 2n plus 1 by 6 minus n by 2 whole square. Okay, so if you're going to solve this, guys, so you will get n into n plus 2 upon 12. Okay, this is the variance. So my suggestion will be, don't mug up anything. You can directly compute using formula. This is just a derivation that I'm telling you, right? Okay, and suppose it is not starting from 0. Okay, it is starting at, suppose this kind of situation is there. Suppose it is starting at a, then a plus 1 and so on, and ending at b. Okay, this is the probability mass function of uniform discrete random variable. So what is this? How many samples are there, guys? Number of samples, you can say b minus a plus 1. So the probability is going to be 1 by b minus a plus 1. Okay, uniform. So इसका variance आप directly लिख सकते हो. That is going to be, needless to remember anything, right? So 1 by 12 b minus a and b minus a plus 2. Here n is nothing but b minus a. Okay, if you mess with the formula, right, so that you can remember, right? Here n is nothing but b minus a. Okay, small n is going to be b minus a, right? Fine. So with this you can remember the formula for that. Formula is same, n into n plus 2 by 12, but as long as if it is not starting at this yeah. Okay, I believe this is fine for all, right? So this is over, guys, and we have discussed, okay, the variance, right? How to compute variance and all. Okay, the next topic that I have to discuss is very important topic, in fact, right? And then we will talk about joint as well. Okay, next topic is going to be the conditional PMF and expectation and given an event. Okay, we have to discuss conditional PMF, conditional PMF and expectation. Okay, given an event, and these are the important topic, guys, for GATE examination, right? So many students ignore this, right? So see, we have studied conditional probability, right? If you have studied conditional probability, so that will not be difficult to understand conditional PMF and conditional expectation, right? So whatever concept you have studied till now for the ordinary probabilities, ordinary PMFs, now we will be talking about these conditional PMF and all, right? And then, and at this juncture, we are going to focus on discrete random variable. And then after, once we will cover the continuous, then we will discuss conditional PDF and everything, right? तो आपको थोड़ा सा पढ़ना पड़ेगा, ठीक है? So let's meet in the next session. Thank you. Keep revising.